Welcome to Microsoft Access Part 4. Today we're going to continue our look at multiple table joins. We're going to learn about different types of join using the relationship selector and other things about making tables more interactive. Up to now we've been looking at a series of tables. I want to refamiliarize you with them because it sometimes gets a little abstract. We have the employees table, which has information exclusively relating to employees. The employee supervisor's name, their hat size, etc. Then orders is a table, we'll get back to orders. Then products, which is a table which deals exclusively with products that we have in stock. Who's the vendor, where it's kept, and its price. Name of the product, of course. Purchaser table has names of the purchasers, purchaser number, an account number for them, their purchaser grade, are they a frequent flyer, etc. Vendors is a small table. We only have 3 vendors. It just gives the list of where they belong, where they are located. Each of these tables, you may remember, is divided from the one big table, which had all the information in one large table. Very convenient, provided it doesn't get too large, because updating is a chore. Updating is also a chance for errors. So the logic of this was to split the one large table, into smaller tables of related items. But then we have the orders table. This is the largest table, which draws information from all the others. It's kind of the master table, because selling stuff, of course, is our central goal. It has the product name, what the order number is, how much it costs, how it's shipped, who purchased it, which employee sold it. So it's deriving information from all the other tables, and all the other tables are linked into it. We'll see that in a diagram diagram later. But I just wanted to refamiliarize you, because sometimes when I talk about how what the tables are, you can lose track because you don't have them in front of you. So imagine we have because we always have missing information. Imagine we have a table of orders and we have a sale, but the employee is missing. We either don't know who it was, or the sale didn't involve an employee. Maybe a manager did it and didn't enter anything. Who knows? You're always going to get missing information. A sale without an employee, a little mysterious, but there we are. That's the world. Then imagine maybe you have an employee without a sale. Poor Jim Dandy, like Gil on The Simpsons, hasn't made a sale yet. Maybe he's new, maybe he's just good at advertising and maybe he's just on salary, who knows. But you see a hole in the order number section of the query because Jim Dandy hasn't made any sales. What do you do when you have these holes? And more importantly, what do you do when there's a hole in the information in the column on which you're joining tables? That's a big problem, because if you don't have anything to join to, where do you situate the information that you are trying to join? Here's another look at it, of course. Query missing an employee missing a job. Okay, right here you remember seeing relationship diagram. We have the merging of the tables employees and order in a query. And employee and order, the joined common column is employee. Employee is the common value between the two of them. You merge the 2 tables on that column and it becomes one table, and you can derive more information. So now if an employee is missing, how do you join? So if an employee is missing, how do you join? If, um, as in query 3, you have an order that doesn't have an employee, how are you going to join that row into the table? You could drop it, which is the default position for access. But you might want to include it because the rest of the information in the row is relevant information. We have different types of join. So far, all we've done is taken two tables that have a shared column, merged all the values on the column, um, and you have what has happened is anything where there's a value that isn't in one of the shared columns, that row has been suppressed. What we can do is uh, we have options to show the row and just have a hole, and that way we have more information. There's something called a join chooser or join properties dialog box. You can see it on the right here. I'll show you how it comes up, and we will make different kinds of joins that are you know convey more information in instances where there's a missing piece of information. Um, the join property, the top part of it, as you see, you select the table and column. In each table, that you select the table and column. In one table, you want to join the table and column in the other table. It's a chooser, and if you drag a line between the two tables, it's automatically set up where you can use this chooser. And then there's three different types of joins that are allowed. First one, only include rows where the join fields are equal. That means only include rows where there is information in the columns that matches up. The second option is include all records from the left-hand side, which is in this instance is employees, and only those records in the right-hand side that have that match. Basically, include all the records from the left-hand side. Um, and a right join includes all the records from the right-hand side. So if information is missing from the right-hand side, that column will still be included. You have to kind of see it to understand exactly what I mean. So let's look at access. Okay, we have an employee uh, we have the, okay, one second. Design view. Okay. What this is merging employee and order field, taking employee name from the employee field, employee number from the employee field. Let's delete that one because I think that's causing a cross join problem. Cut that. Um, delete the table. Delete the table by highlighting and hitting delete or cut. Okay. And we have employee from the employee table, product from the orders table, and purchaser from the orders table. And here we have, this is a inner join. It only joins the rows which have a complete set of entries. As you can see, each row has a salesperson and a purchaser and a product as expected. If we go into a design view, click on the link. The way we do this is kind of special. Click on the link to highlight it. It turns a little darker. Right click and join properties comes up. You can see the join properties window is there. It's selected number 1. Only include rows where joined fields from both tables are equal, meaning only include information where the row is complete. Now, let's switch the join to 2. Include all records from employees, including records where the employee is blank. So here we have a query, employees plus orders. You click on the join line, it gets a little darker, hit right mouse and join properties window. First I'll do this again, we're going to select the default, which is only the rows where all the information is complete. Any row that information is missing is not included. This is called an inner join. It's option 1 in the chooser. Go to option 2, join properties. Select 2, include all records from employees and only those records from orders where the joined fields are equal. And you'll see employee exists even though there are no orders to his name. So this is vital information in some instances. The first default setting for joins would have suppressed it. The design view. Again, join properties 3, include all records from orders and only those records from employees where the joined fields are equal. So this will bring up orders that don't have an employee. See, missing employee. There's something called a full join, which would include also this, the row where there's a employee but no order. Full join is not an option in this chooser mechanism. You have to, as far as I know, you have to use SQL to get that. So to reiterate, we have inner join, which suppresses anything that doesn't have a complete row. Left join, which will include the employees without orders because employees on the left side, and it favors all the information on the left side. Right join, which includes all the information from orders, even if an employee is missing. So again, all the information is very nicely laid out in the join chooser. So you can see the implications as you're going. There's a whole bunch of joins that need to be memorized eventually, but this chooser makes it very easy in the first stages. So we also need to look at the chooser in the menu ribbon. There's another chooser. Another way to, 2 other ways to look at the chooser. Design view. You can just right click by not highlighting the join. We did the first time. Right click and bring up a broader menu section, but it's a little more confusing, and I don't like this chooser as much. This takes you to the relationships. Do that again. Select relationships here by right-clicking on the blank field, or going to Database Tools, Relationships. And what you have now is a relationship diagram for the entire database, or at least schema, which is all the related tables form a schema. This is really useful. It shows you, like we said before, orders is kind of in the center because it derives the most from all the other rows, all the other tables. Orders, information from employees, products, and purchasers feeds into orders. There's also a table of vendors, which feeds into products, so it only indirectly feeds into orders. Nothing directly from vendor shows up in orders, but you could include it anytime you wanted to knit information, anytime you wanted information from any of these other tables, you kind of knit it together, uh, and it's most likely going to contain real estate from orders, because orders is the largest, it's the widest table, basically because it has the most columns. So it has the most relationships. And the lines between the all the tables are the shared columns. Um, None of the columns are primary keys, but in this case, um, in each of these tables, one of the columns will be unique. Employees is a unique non-repeating column in employees table. Um, Purchaser is unique non-repeating table in or column in purchaser. Products product is the unique repeating uh, unique non-repeating table in products, and in orders, order number is the unique non-repeating column. So you can edit relationships using the edit relationship um, chooser. This gets a little more complex. We're not going to deal with this right now. Um, with more complex databases, you may have more than one way to link a table together with another table. Different tables may have more than one shared column. It gets very messy. So I don't want to use this edit relationships chooser. Basically, you should you can go to the relationships diagram under the relationships under the database tools under the relationships design ribbon to see the entire schema, but I would edit it on a query by query basis. Highlight the line, hit the drawing properties, and use this chooser to decide whether you want inner or right or left join. You're not really going to do too much right or left joining at this time because it's complex, and also it has knock-on effects if you're trying to chain tables together. But you need to know that right, left, and inner joins exist. No, we don't change it. So now we want to talk about queries. Queries are tables, and we take two tables and combine them together, and we get another table which has two shared columns that become one column in the larger table. But a query is not really a table in that it's more a list of specifications. It produces a table whenever you want one. The base information for all the data in a database resides in a table. It does not go into a query unless it's first in a table, unless it's a calculated field, which we haven't dealt with yet. So query is basically a question waiting to be asked. But what we can do is we can use, once a query is created, we can use it as a table and chain queries together. This is very useful because queries can create temporary relationships which you don't want to be persistent, and you can query off them. So queries update whenever a table is updated. And so it's important, since they're taking all their data from tables, it's very important that you not delete the underlying tables or the query will mess up. The query won't be able to do anything. So anytime a query exists that derives from a table and you try to remove the table or parts of it, you'll get a warning message saying this query will no longer be functional. And you, like a, so you've got to be careful before deleting tables or columns in the underlying data. Um, this is why forward-thinking table design is also important. Before you create a database, know how your tables are going to split up, how many you need, and how each one uh, represents a particular characteristic of the data you're keeping. So there's a table query chooser which you use when you make new queries. You're deciding where you source your information from. You want to make a query from tables, you use this chooser to derive all the tables. And you can use this chooser to pick queries that you want to use as well. You specifying the columns on which you're going to join the two tables. So what we've been doing up to now, if we wanted a query, is we just drag the information out. Sorry. What we did in the past was just drag. We'd go into query design. Let's close this. What we do in the past is database tools. We actually go to create, query design, and then we drag the tables we want out into the field. And some once may have said that Microsoft finds the joins. That isn't really the case. If you've joined the tables before, Microsoft remembers the joins. So you could just drag the fields out, but you can also just use the chooser over here, a little neater. Add selected table, employee, add selected table order, and it already has all that information there. But we can also do, all the queries are listed, and you can select the query you want and bring it out. Very useful. But today we wanted to join query 3 with orders. Query 3 joins employee and order, and derives employee and order number from the employee and orders tables into one table. And then we query order tables again to bring up purchaser. This seems a little absurd. Why not just use, you should be able to do the same thing. Without involving orders in the original design of query 3. But I'm just doing this to show that a query is just like a table, and you query from it. You can use it to query from. So let's use query 3. And orders, which is a table, and go to the chooser. Now, have to decide what join is going to exist here. Order number is the join condition because that's the shared column. And we wanted employee, go to table, query 3, select employee. Then we're going to go to either query 3 or orders, either one, and select order number. And then from the orders table, we're going to select purchaser. And run it. And now we have uh, a query on the left-hand side and a purchaser on the right-hand side. And sometimes it's just more convenient to, if a table is very large or complex, um, you can make a query derived from a couple of tables that's very small, and then if you want to query it against another table or even itself, it's a more efficient way um, of getting information out without involving too many other columns that are extraneous to your query. So very simply, in summation, you can treat a query just like a table, even though a query is more like a set of specifications that only brings a table into being when you need it. You can treat it just like a table. So again, we made the manual join um, by just dragging the line between order numbers. There is a relationship chooser, like we saw, which allows you to specify which um, columns you want to join on, but dragging the line at this point is just easier. The relationship chooser is helpful, though, if you want to specify a special join, like a right join or a left join. So let's join three tables, just for the fun of it. Here we have employees, orders, and products. It's kind of the same join that we made before, where employees and orders were merged into a query, but I want to show you how easy it is to just chain them together. Create, query design, choose employees, orders, and products. See, the joins are already in there. You can select employees, employee, orders, order number, and products, product name. Notice I'm using the shortcut way here of, um, I'm not, in the chooser below, I'm not selecting table and then selecting column. You can do them both at the same time by uh, using the uh, compound terminology, where you have table and column name uh, displayed together. See right here. You can select the particular column you want in this instance, because the table and column name are binary paired here. It's just a time saver. Let's run the query. And you see one column from each table. And this information could not be joined together except by drawing the information from the three tables, because the information, as you know, first column is from the table about employees. Second column is the table about orders, and third column is a table about product. Each of these types of data is unrelated to the others, and so the join is how you get them to sit together on one table. We can even join four. Here's the chooser that we use to select them, and here's the result on a slightly larger scale. We could technically, since product is a join table of both employee and product, we could choose either one of those columns to be the column displayed. Doesn't really matter because they're the same column. but we can join four tables. This is a little absurd. Sometimes when you do these, you're more likely to have joined the tables into queries and you're joining the queries, but it's not impossible. I'll just show it to you. We already have the four table query set up. As you can see, employees from employee product, employees from employee table, product from orders table, vendor from products table, and vendor zip code from vendors table. Why would this be useful? Imagine we got news that there was a flood in Peoria. We know we might have a vendor in Peoria, and some of the stock that has been ordered might be damaged. So the employee needs to be told so they can contact their contacts and say the item might be damaged, may not come. So this table, if we look at the relationship diagram for the entire table, we'll see vendor zip code is all the way out here in the vendors table. We know that there was a flood in Peoria, so we get the Peoria zip code, and we get vendor zip code from the vendors table, and it's included in our query. On the join condition that comes out of products. We cannot get to vendor zip code without merging vendor and product table. Orders cannot get to the vendor zip code without merging first with the product table and the product table being merged to the vendors table. Make this a little more concrete. Okay, we know the Peoria zip code is 49494. So we line up all the vendor zip codes on the left. We know the manufacturer located in that zip code, the product they make, and who sold the product. So we have to go to Tammy and Jackie and say, look, this factory in Peoria, we've just learned Peoria has a flood, so you have to tell your customers that this item isn't coming. We could include the customer. We could include the customer name as well. Let's insert that into the design. Product orders. We can just tack it on to the end. Orders customer. Orders purchaser. Hey, Jackie and Tammy, you have to call Tim, Sean, and Tammy. Let them know their product isn't coming. We could drag this over so that it's closer, but of course, none of this is possible unless you've succeeded in merging all these tables, all the way from here, all the way over to vendors. We're including all five. We're not including purchaser table here. Purchaser exists in orders. We're including these four tables here. It's a broad query, much more complex, and shows you the true power of the relational database. Here's another example. Imagine we have an incentive. Well, this is just the zip code thing again. I want the zip code of vendors who have had their products sold by which employees. I want to know which employees have sold products from a given zip code. So that was a lot. Thank you for watching. What we did was we joined multiple tables, which we've done before, but we learned about join conditions, right join, left join, and inner join, which allow us to emphasize the complete, which allow us to include complete information in right or left tables, even if there's no matching information in the other table. We also learned about the inner table, which only joins rows which are complete. So that way, if an employee doesn't have sales, he's still included, or if an order doesn't have an employee listed, it's still included. But again, these are options we have to do when we go into the chooser. And then we showed how a query acts just like a table, even though a query is not a table. It's a list of specifications that produce a table. And we combined 3 and 4 tables into a query, so you can see how powerful it is. Broad ways you can go across a broad swath of information, select exactly what you want, and leave alone stuff you don't want. Let's go back to to the relationship diagram. I could just pull this up for success. Let's go back to the relationship diagram. Purchaser does not, the purchaser table in this last broad involved query does not need to be updated, does not need to be consulted at all. All the information regarding purchasers, the only information we needed was already in the orders table. If this were all one big table, we'd have to update all these tables. Whereas in this case, we left out needing to update the purchaser table, which cuts down on read-write energy, and it also prevents transcription error when you are forced to rewrite a table, save a table that you don't need to do. And so next step, I hope you join me again. Look for the card. We're going to work on full database relationship diagrams and rationalizing table design. We're going to learn about different types of correspondence, one-to-many correspondence, many-to-many correspondence, and one-to-one correspondence. Thank you very much, and have a good night.